All right, I wanted to do a little demo on how JavaScript interop works in Onyx. It's a relatively new feature, so it's a little bit in experimentation, but I think it's really cool, and so I wanted to share how it works. Um, you can read the documentation for it on the Onyx core packages reference. There will be a better guide for it soon. I really need to update some of the guides and reference material that's out here, but for right now, the documentation is probably your best place to find it, and you can just read about it in the core.js package. And so there's all this stuff, and I'm going to kind of go into the weeds of how all this works and how you're kind of intended to use it. It's a very low-level JavaScript API, so it's not necessarily the most friendly thing, but it does enable developers to interact with JavaScript at some level. So now you can build things like, um, you know, frameworks and even just wrappers that make the DOM type safe and stuff like that. So let's get kind of going. And so let's first create a project to do all this stuff in. I'm going to use the Onyx new command, which is going to give me an error because what new does by default is it will just create a new project in the current directory, which it won't do it if you if the directory isn't empty. So I'm going to need to specify a directory name. So I'm going to say Onyx package new, or you can just say Onyx new as an alias to that. And then it wants a template, or you can use it to list out the templates that are installed. Right now, I just have the default template. So I'm going to use the default template, and the directory name, I'll just call it JS demo. So project of this, right? All these things that you're filling out are really just used to populate. If I go into that folder, I cat out the Onyx package file. That's really all these things you were setting up here. They just populate the fields in the metadata of this package. They're not really used anywhere else. So it doesn't really matter what you put there. Okay, so let's hop open into like Vim or something, and let's look at the main file. So this is loading any packages that we would have, which there are no packages because there's nothing in this. We don't have any external dependencies. We're including the print line function, and then we're printing hello world. So right off the bat, you can compile Onyx to run on JavaScript without doing anything else. The JavaScript interop is more for when you want to actually do something with the DOM, but just to show that like you can compile to JavaScript and run it in the browser. I'm going to use the Onyx build command, and if I run the help for it, this was a bad idea. There's not enough screen real estate here, but there's this flag for the runtime, which is effectively the environment that Onyx is going to be executed in. There's the Onyx one that's specific to the Onyx compiler and like the Onyx toolchain. There's WASI, which is WASI Preview 1 compatible, hopefully soon to be WASI Preview 2, but it's in the works. There's JS, which is what we're going to be working on now, and then there's custom, which is nothing is defined, but if you have a custom environment like WASM 4 or something like that, you can use custom. But we're doing JavaScript for today, so we're going to have to compile with the R.js flag, or runtime.js. And I think that's all I'm going to really need to specify. So if I come back in here and I Onyx build R.js, and then I build the main file, that'll create two files over here, out.wasm. My dog is having a fit at something in the background. That'll create an out.wasm and an out.wasm.js. So basically, this WebAssembly file is there to actually have the Onyx code, and this JavaScript file we'll dig into a little bit more, but it contains all of the wrapping code needed to execute this WASM file, in addition to all of the extra stuff for the JavaScript interop. In theory, this file could be smaller in this case because I'm not using any of the JavaScript interop, but it's fine for the most part. You're likely going to always use the JavaScript interop at some point, so it's just always included. So to actually get this to be something on our browser, we have to make a index.html page. So maybe what I'm actually going to do is I'm going to add a new folder called dist, which is where the actual stuff's going to live. And so maybe in here, I'm going to remove out.wasm and out.wasm.js. And what I'm actually going to do is I'm going to configure a build for this project. So what you can do is you can create a build section of your CUDL file. And in here, you can define different build configurations that effectively just run the Onyx build command for you with different configuration parameters. And so I'm going to create one called default, which basically just means when you run Onyx package build, you don't need to specify the build config. It defaults to default. Otherwise, you can have more in here. So we're going to define one for default. It takes, I have to remember the name of these parameters. I think it takes a parameter called source, which is just the source file. You can have as many of these as you want, and you can list out as many source files as you want. This project only has one. It's going to then also take the target, which is going to be dist out.wasm, is where we want to store that. We could call it maybe like app.wasm instead of out.wasm. Maybe that's a little bit better. We want to specify the runtime as JS. And I think that's all we need to do to compile this. So we can test this by running, let me clear the screen, Onyx package or PKG build. And it says compiling with the build configuration default and successfully compiled. So that tells me that that this did work. And if we go into that dist folder, there is the app stuff, just like we'd expect. So in this dist folder, let's also make a file called index.html, which is just going to be a basic HTML page that we're really not going to do anything with. We're going to get rid of the CSS. We'll put a title in here of Onyx demo. We're not going to put anything in the body, and we're just going to create a script in here that's going to actually load that JavaScript and run our stuff. So the way I'm going to do this, just because it's a lot easier to do it with ES6 modules, is use the type module. I can then import Onyx from the app.wasm.js file. I can then create my app as you have to await onyx.load app.wasm. Right, so this specifies basically where your WebAssembly file is. The reason why this is kind of separate and not baked into the JavaScript file is because I don't know how you're separating your JS versus your WASM. They might be in the same directory, they might be different, so I make you specify where this lives. You can also use the create method that's defined in here, which is used if you want to give it the array buffer of WASM code. So if there's a different scheme you want to do, you can do it that way as well. Load is just short for fetching that source, awaiting it as an array buffer, and then creating with the code. So we're just going to await the load, and then we can call app.start. So this start is going to effectively call the start of our WASM module, which will initialize everything and then land us in our main. So that should print out hello world, and that's going to print in the command, or not the command line, the console. So if I compile this, I think this is all working. So now I'm going to go into the dist folder, and I'm going to run a simple Python server that just hosts this folder on localhost. And now I can hop into Safari and open this. As you can see, it was served. And if I open the dev console and make this as big as I can, you can see it says hello Onyx here, right? If I refresh, I refreshed and new tabbed. See, it says hello Onyx. So that looks like that is working. So let's actually talk about how to do real JavaScript interop, right? Because at this point you can write like, oop, that's me, and that's not what I wanted to do. So at this point you can write any Onyx code you want, right? I could write a for loop, right? I'm gonna loop through X from 1 up to an equal to 10, and I can print line X, right? And I can, sometimes the Alt tab on Mac is just silly, to put that in a nice way. Okay, so I can rebuild this, and then if I just go over here and click on Safari, right click, inspect element, come back here, refresh, 1 to 10. Perfect. So, right, any program that does just standard output, you can write, and it will just print a console, right? And of course, I haven't actually tested using this with Node, and in fact, that's kind of just unsupported right now. I was mostly focusing on doing stuff in the browser. In theory, you should be able to import this in a Node module. You'd have to use create and load the WASM code buffer using like the FS library. I haven't looked into that too much. I was mostly focused on the browser, but that is somewhere that this could be improved for sure, is a more node compatible way of loading these things. But for right now, we're going to focus on the browser and doing things with the DOM. So let's look at how we could create a new, let's just say, button element and put it on the page, right? So I'm going to close out of some of these things, right? We're not going to need to modify the index.html, and all these files are kind of generated. So now we're really just going to be focusing on our main.onyx file. So to actually use the JS interop, you have to use core.js. This makes the JS symbol available. And if we look at some of the documentation for it, right, the primary thing that you are going to use is this thing called a value, which, as you can see, it is a distinct U64. So we'll talk about the details of how values are stored in just a little bit. But basically, this is a handle to a JavaScript value. So you can use it to store JavaScript bools, floats, ints, strings, and then any JavaScript object, right? Like a DOM node, a map, an array buffer, a promise, whatever you want to store. So that is that. And I don't think the documentation generator needs a little bit of work. And I don't think the important thing I want to show you is even on the documentation. So the important thing that you'd want to be able to do if we want to create a button, of course, is to get the document, so we can call document create element. The way you do that currently is you say js.global. This is a constant that is, well, defined in the JS library, not unwrap. What am I trying to do? Get. So this constant is defined. Let me see if I can go to definition. That does not seem to be working right now, which is a little interesting. But this is defined in the JavaScript library as just the window, basically. On Node, it's technically the global this, but it's effectively window when you're in the browser. So we can use window, then the get method, and provide the document. Now the get method is effectively just there's some weird bugs in here. I was hoping this was going to be a little bit nicer, but ultimately, get is effectively the subscript in JavaScript, right? So this line up here is basically like saying window subscript document, which is effectively the same thing as saying window.document. So, right, it's a little bit more verbose, but that's how we have to do it in Onyx right now, right? Now, if somebody wrote a DOM library that we could say DOM, we could then say maybe dom.window.document or something like that. But right now, this is what we got. Okay, so we have the document. Now let's create our button. So we're going to say our button is document call create element button. So remember from JavaScript, you can use the create element method on documents to create an element, and then you pass in the tag name of the element to create. So the way that call works is it treats what's on the left-hand side as the this parameter, and it looks up the method inside of it, and then it calls it with that as the this parameter. And then this is like the first parameter that goes to it. So if we look up call, it's always a method and then a varargs list of any's. And these any's are automatically converted to the necessary JavaScript value types. Not every type in Onyx is supported to be passed through to the JS API, but all the common ones like any numeric type or strings, arrays, slices, maps, if it's a map of string to anything, those are supported, but so map of string to anything maps to like an object. That's the keys are the keys of the map, and the values get mapped kind of recursively. So, but this will create us our button, right? It returns that JS value. So we now have a handle to our button. Let's set its inner HTML. So we can use the set method, which is basically, I'll type this out. So this is basically equivalent to button.innerHTML equals click me. Right, that's what set is doing. It's taking the left-hand side and making it the thing you're going to set something on. Then the first parameter is the thing you're setting, and then the second parameter is what you're setting it to. So, right, just to review the documentation, set takes the property, and then it takes either the JavaScript value or any type, and it will convert it for you. Okay, so that is set. So now our button should have that text. Now let's add it to our document. So we can say document, we have to get the body, and then we can call append child, or I think you might be able to just call append, but I'm gonna call append child of button. So, right, we have to say document, effectively dot body, and then dot append child, and call that with button. So let's see if this works. Let's Onyx package build. Oh, right. It's messing around. DOM is not a real thing. Okay, we do compile successfully. I think my Python server is still running. Oop, I hit Control T. Okay, if I make this as big as I can, we now have a button that says click me. And of course I can click it and nothing happens. So maybe let's make something happen. Let's throw up an alert whenever it gets clicked. So the way that we create sort of event handlers in JavaScript, well, in Onyx for JavaScript, is, I mean, it's just like JavaScript. We just need to call the add event listener method. We pass in the event name, which in this case is going to be click, and then we pass in the callback function. Now, to do this, we can, I believe we can use just an Onyx function that has a certain type, but if we want a bit of type inference that makes it a little bit nicer, we can use a special function called JSFunc. It takes a function as its argument and it will wrap it in an Onyx. Well, it'll wrap the Onyx function in a JavaScript function that can be used to call. And I believe I made it work where it will implicitly happen if this inner function has the right type, but I do not remember, so I'm not going to test it. Not on this demo. So basically what every JavaScript like interop function from Onyx will take is a this parameter and an array of args. So this is just like the JavaScript this, right? Every function call has an implicit this argument, whether you specify it or not. And that's what this is. It normally can be ignored unless you're going to use it. Of course, that was the most redundant thing to say. But then the other thing is an array of arguments. And this is a actual Onyx array. Like if I were to give this a type, it would be a slice of JS values. So we're just going to do this, and this will infer the type for us, and all will be good. Okay, so now in here we could honestly do whatever we want to do. Let's just say we're going to call the window alert method. So that's going to come from js.global is our window. And we're going to call alert with the button was clicked. Right? So now let's try to compile that. And okay, we get an error. So let's kind of look at what this error is saying. The procedure from, which is, that's actually a bad error. It should say func, but func is actually just an alias to .func.from. So this error makes a little bit more sense. But anyway, the procedure func expects a value of type value, slice of value, returning a value for the first parameter, but it got one that takes a value and a slice of values and returns void. So this is an ergonomic thing that I think I'm going to improve in the next version, but right now you have to explicitly return js.undefined. If you return void, it does not implicitly convert that to undefined. So you have to explicitly say that. I think I'm going to make it so if you leave off a return type, it assumes void, and that therefore it will assume returning undefined, which is more like JavaScript semantics. But that compiles, and so now if I refresh this page and I click the button, we get an alert. Button was clicked. So that's pretty cool. Right, this is a callback that's happening in Onyx, but it's routing it kind of through JavaScript, which is pretty neat. So the documentation and the source code does an even better job of talking about what goes into all of these functions. When in doubt, I would encourage you just to read the source code. It has all the doc strings in here, and it's a little bit more thorough. It's not that intimidating to read, I think, once you get into it. You can see the definitions that got left out. Basically, they're just special values for undefined nan 0, which you don't have to use this one. You can just use the literal 0 and it will still work. Null, true, global, and Onyx, which this Onyx one is the Onyx handle itself. So when you create the new Onyx, like when you say onyx.load, it also puts its own handle in a place where you can use it from within here. And so if there's any state you want to use, or if you want to introspect something on the internal details that we're going to talk about next, you can use that. And I realize this is probably way too small. Probably way too small to read. But yeah, there's all these special definitions, and then all these methods that you can use. So let's kind of get into some of the internal details of how this all works. So I'm gonna save and quit. And then I need to remember. I'm just gonna kill all Python. Cool. Okay, so let's hop into Onyx and let's look at how the JS stuff works. So we're gonna start by looking at. Let's look at the JS value, the code that I have open on the other side of the screen. So, like I said, values are just a distinct U64. So distinct in Onyx simply means that it's a different type than this, but internally it's treated just like this by the compiler. So the compiler can use all of the like storing logic and internal stuff like that, as it does with this type. But from the type system's perspective, it's entirely different. And so you can't just pass a U64 for a value. You have to explicitly cast it. All the operator overloads are different for the value type compared to U64. It's an entirely different type. It's almost as though it was a structure with like a single definition, but a little bit nicer because you can actually cast to and from. So you can cast a U64 to a value and not have to do any weird struct creation or anything. So that's what a value is internally. So just like in JavaScript, every value has one of a very few types. There's honestly not that many types in JavaScript. And they're all encoded here in this enum. You have undefined, null, bool, number, string, symbol, object, and function. This is what's returned from, I think it's, the value type. So it just returns the internal type of the value, which you can use to do any kind of logic that you would like to do. So the way that these values are actually encoded, right? What goes into these magic numbers? It's actually the same trick that Go uses. This way of doing it was heavily inspired by Go, and I can't take really any of the credit for the way that this is done because it's just kind of true genius from the Go team. So I'm not gonna say I invented this at all, but the basic idea of this is that you treat this U64 like it was a 64-bit floating point number. And if you don't know, 64-bit floating point numbers have, I'm going to get the numbers wrong. They have one bit that is the sign bit. Then they have, let's do a little research. 64-bit floating point. Double precision floating point format. So this is what they look like. They have one sign bit, 11 exponent bits, and then 52 fraction bits. The basic idea, hopefully you maybe understand what a floating point number is, but the idea is that the sign encodes the plus or minus, the exponent encodes, like in scientific notation, you write it as like 2 to the exponent, and then the fraction bit encodes the mantissa, which is like the part that's after the 1. So it's always a 1 point something, and then times 2 to the, they write it as exponent minus 1023 because it's a signed exponent, and so you can kind of write it this way. So anyway, the idea is that there are special values that were set aside for floating point numbers. So I bet that they will talk about these somewhere. Maybe. Maybe. I was hoping they would. Okay, so this is in the double floating point. Okay. So, okay, if your exponent is 0, it's used to represent signed 0, which basically means a sign can be plus or minus, and those are actually different things in floating point because, of course, they are. Or if your mantissa is not 0, they're called subnormal numbers. Not going to get into that. The important case is if all of your exponent bits are 1. If all of your exponent bits are 1, that is used to represent infinity. If all of your floating point bits are 0, and nan, if any of the mantissa bits, is what I meant to say, if any of the mantissa bits are not 0. And so what this means is that when all the exponent bits are 0, there are 52 bits that can be whatever you want them to be, so long as they're not all 0, and they're all technically not a number. Right? Which feels wasteful, but they had good reason to do it this way. But what you'll notice, this is actually a funny representation, and maybe a bug, honestly, with how I have this implemented, but oh, no, it's not a bug because it has the 8 up here. So, yeah, you look at the first, basically, 3 nibbles, the first 3 hexadecimal numbers, and these are used to represent these things. So, because all these start with 7FF, these are either going to be not a number or infinity. Well, because of this 8 here, none of them are infinity, and so they're all not a number. But the whole idea is that we can store extra data in that not a number area, and it will still just be not a number. So basically the trick is you can store a normal floating point number just like a normal floating point number, right? If we look at how, it should be down here somewhere. I forget where, I thought maybe I did it in JavaScript. I thought I did this part in, yeah. Oh, right here. Okay, so the way that a floating point 64 number, float 64 is encoded, is it just takes the data pointer, casts it to a pointer to float 64, and then dereferences it. Right, so basically gets this thing as a floating point 64. And then it just takes the bytes that represents, and casts it to a pointer to a value, which remember is basically just 64 bits, and then it dereferences it. And this means that it's going to interpret those bits as just a U64. And then later we'll use to test if they're not a number. Of course, there's that special case of how do we encode 0, because 0 is a little bit special in how this all works. So 0 has to be encoded just differently. And that's okay, but we just have to handle that. So anyway, that's float 64. And all these other cases are basically just casting everything to float 64 and then converting it into the value in kind of that same type punning way. Even I64s that technically would lose precision, JavaScript can't store 64-bit ints to a good precision. It won't lose any precision on the 32-bit numbers because remember 32-bit ints can be perfectly stored in a double floating point number because of the well, there's 51 bits in here that we can control, and so because 32 is less than 52, we can perfectly store any 32-bit number. We can't store any 64-bit number because 64 is greater than 52. So there we're going to lose a little bit of precision, but that's considered fine. So anyway, we basically just type pun our way to get these things into being values, and we have to just check for that special 0 case, right? Otherwise, what we do for other types, let's look at, I forget, where's the other important code? I guess it's probably just in the JavaScript side. So maybe it's time we look at that. So to go along with this file, right, all these JS values, most of them break down into calling these like double underscored functions. And these functions come from the foreign file that's also in Cora.js. And basically, these are package level symbols, so they're not things that you're able to see, but basically they just contain all the wrappers to the JS functions that actually do the interesting stuff. And also notice here, there's the JS directive, which is how this file is actually included in the compilation. And so by having this, that's why we get the JS file outputted when we compile. So basically all of these have a corresponding definition in onyx.js, which is the file that was referenced above, and we've kind of peeked at before. But basically, I guess I should explain this. So the JavaScript heap is basically a really simple array that just stores all of the values that are used in this execution. So you can allocate to it by just inserting a value, and it will give you an index back. So when you insert, you'll get a handle to it, and that'll basically just be the position in this array. When you free, it will take that thing, set it to be undefined, and then add that index to the free list so it can be reused later by insert. And then you can just get the value at a particular index, right? Or you get a console error if you access out of the heap bounds. So we'll take a look at how that really plays into it in just a second. But if I look here at store value, this is the really important trick. What we do is we have those header bytes that we know that if our number is prefixed by these, it's nan, and it's going to encode some extra data. So what we do, if we're storing, so I guess I should say, store value is called by JavaScript when it wants to give a value back to Onyx. It needs to produce this JS value type from in here that Onyx can then use to reference whatever JavaScript object we're dealing with. So if that's a number and not 0, of course, we first have to look for, if that value is not a number, we have to encode that it's not a number, which basically just means we put down the not a number, we set the rest of the bytes to 0, and then get that as a 64-bit number. Otherwise, we can just do the normal case of setting into the scratch buffer a float and then getting out a 64-bit int. This is the equivalent way in JavaScript to do the like type punning, where we say, take all the bits that make up the float and treat them as a big integer. Okay. So that's the number case. Basically, we're just type punning a float to being a 64-bit integer. If it's undefined, that's a special case, that's 0. Otherwise, we take our value and we insert it into the heap, and we get out an index. So this index is basically our handle into the heap of how we're going to reference this value later. Then what we do is we switch on the type of that value, and we're going to encode that type into the number that we're building. So basically, the trick is that the type flag of 0 is going to be null, or undefined. I forget all they don't line up with these. It's a little bit different. So null is encoded as 0, but objects encoded as 1, strings encoded as 2, symbol 3, and function 4. Then what we do is we're going to say the upper 4 bytes are that nan header ORed with the type flag. So basically, it's going to take that header, it's going to OR in that type flag, which basically, if it was a string, it's going to set this last nibble to be 2. If it's a function, it's going to set it to be 4. If it was null, it's going to keep it as 0, right? And it's going to encode that little bit of extra type information here at the end. And then in the lower 4 bytes, it's going to put that index, right? Because remember, we can put whatever we want in there and it will stay not a number. And so we're going to just put in that index to the heap into our 64-bit number. And because of this header, we know that it's not a number, and we know the type of it. And so we do the same kind of, it's not quite type punning here, but avoiding the bit shifting weird math that can get funky in JavaScript, we're just putting things into a scratch buffer and then loading it as a 64-bit number. And that's what a lot of this does. So that's store value. Let's actually look at load value really quick because it'll kind of make sense how we go the opposite direction. Basically what we do is we first type pun it in the other direction. We store, like, set a big int and get out a float. So read the bits as though they were a float. If that floating point value is 0, that's a special case for undefined. If that value is not a number, right? So if it is a valid floating point thing that's not a number, then we just return it as the float, right? So all numeric types don't like get put into the heap. They're just encoded as normal types. Otherwise, what we do is we simply mask off those lower 32 bits, treat that as just a number, which is basically how JavaScript goes from a 64-bit number, or really a big int, which could be anything. It goes from that into just being a normal 32-bit JavaScript int. And then we take that index and we get the thing out of our heap, right? So when it's not a number, it's referencing something in the heap by using those like extra bits to encode the index of that. And when it is a number, it's a floating point number, which is like the only way JavaScript stores numbers. Okay, and that's most of what this does. So, right, if we look at syscall, basically this is the thing that's encoding all of these like operations, like the set that we looked at, the call that we looked at. All right, let's look at set. So what set does, right, it loads the value that we're going to be setting. It loads the new value that we're going to put into that place. It then calls this thing called extract string, which, as you can guess, it takes the pointer and the length of a string from Onyx and extracts it into a JavaScript string. And then it uses the reflect API to set the name on that value to be the new value, right? And so, you know, it's kind of equivalent to saying this, but I've heard that the reflect library is supposed to be a little bit better and more sane, but it's basically that logic. Okay, same thing with dot, right? That just does it for the, right, we're not setting anything, we're just getting it out. Actually, dot's a good one to look at because we're going to do the same stuff. We're going to load the value, load the name, but then when we get that thing from reflect, we're then going to store it in our heap because we can't pass a full JavaScript object back to the Onyx, but we can pass that handle from our heap. So basically all these functions are just loading things from the heap and then storing any results back to the heap and going back and forth, right? Same thing with call, right? All we're doing is, well, we're loading a slice of values, which is a little bit special. Then we're loading the value itself, and then we're going to call that JavaScript function, right? Passing undefined as this, and then passing in the args as well. I actually need to double check this because I thought I shouldn't pass undefined here, but maybe, I'm sure I looked at how this works, but to me it seems like this was going to pass undefined for the thing, but I think that would break how a lot of things work, so I think it's working. Oh no, my bad. I named things rather poorly. So call, if we look at call, which I thought, I need to just search things. Call actually uses the thing called method, and then invoke uses a thing called call. Terrible naming, I should fix that. But this one is for invoking a function without a this, and then this is the one for invoking a function with a this by looking up the method. So I was getting a little confused there. There's also how you like make the function. I'm not going to go into all of these details, but it basically involves getting the function from our function table that's returned from the WebAssembly API, and then we call a special thing called allocate arg buff, which is defined down here. Basically, it takes the number of args and it produces a buffer that uses the Onyx heap allocator to take in the args, or to like create the buffer for the arguments. And then after it has that pointer into the heap where it can write these things, it writes in all the values, right? Just taking the arguments to this function, storing them at their particular offset. It then stores the this argument. It sets the closure pointer, which is important because then that's how you can get closure callbacks from Onyx. Or like, yeah, you can pass a closure and it will keep the closure. And then it invokes the WebAssembly function, passing in the arg pointer and the arg pointer like length, and the this arg, right? So that's what forms the this and then the arguments. Then I am very confused. I thought this. Oh, it has a very bad bug. How did this get to production? Okay, I'm fixing that bug right now. I'm glad I don't really use that. How? I don't know how I missed that. I need to take the value that comes back from here, and I need to return from this JavaScript object instance load value result, right? Because it needs to actually return whatever I specify. So that was a bad bug. That's gonna get pushed to nightly tonight. Okay. Anyway, but it takes that result and it will then free up the arguments that it made, and then it will return that result. And then that's how that works. So like basically then this whole function closure is passed to store value, and that's what actually gives us the JS value handle back that we can then pass around. So we can reference the function that this creates. And then there's just other little helpers for like converting strings or copying data from array buffers to and from Onyx. Because this is kind of a common thing you might want to do is like direct copy data instead of like passing it through a string or something like that. So that's basically what makes this all work, is it's just abusing the fact that floating point numbers have extra bits in them when they're not a number, and we use that to encode whether or not we're looking at a heap value or not. And then certain values like true and false, null and 0 are given special things actually in the heap because it's the easiest way to encode them. Same thing with, so global this, that's basically window and or global this if you're in Node. And then I talked about the Onyx handle. So that's how all of this is working basically. Now, you might be thinking, well, I allocate things into the JS heap a lot whenever I pass something in. How do I free these things, or when are they freed? So it's a good question to have because it's important to understand. When you're dealing with these functions that take these arrays of arguments, they all use this special macro called transform args, which is defined down here. And it basically keeps track of all of the arguments that you passed that were not values or functions. So to briefly mention, there's also a JS func, which is basically a wrapper around a value. And this is the thing that we were using to create our thing, right? So we make our function, which was the big function that we looked at over there that creates the closure, right? That is what a func is. So we look at, if you pass a value or a func, it just gets added to the list of arguments. But if you pass something that's not a value or a func, we have to convert it to a value or func. And when this function does that, it also adds it to this array of things to free. So automatically anything you pass as a function argument that gets passed to JavaScript, it'll be converted to JavaScript, allocated on its heap, and then automatically freed. And that just keeps it, a little bit sane, right? You don't have to think about freeing every single argument. However, you do need to think about freeing the result, right? In our demo that we looked at, we allocated the body and the button, and all these were handles into the JS heap that, in theory, could be cleaned up. And so, to help you do that, instead of having to manually keep track of everything, there is this extra thing called a value pool. So the idea of a value pool, as this kind of suggests, it's just an array of all the values that are currently being kept. And it has a very simple interface of just adding values to the pool, removing values from the pool, and then being able to release everything that's currently stored in the pool. So, you know, you can add these to the pool and then call release all when you're done with all of them. But to make this even easier, there's also a default pool, or I think I call it the current pool, which I forget even where the current pool is stored. I bet it's actually stored in foreign, maybe. It's not. Somewhere the current pool is stored. I'm not going to search for it. But right here. It's actually a thread local pointer to the value pool. And to set up this pool so that way you can use it, you call setup default pool, and that constructs the new value pool. And then once you've set this up, you can call release pooled objects, which, so long as you've set up the current pool, will release all of the objects that it has stored. So the idea is that, kind of like the temporary allocator, you can just set this up once, and then everything will automatically be added to it. I didn't point that out, but at the bottom of all of these functions that allocate something, they all call add to pool, right? Transform args has it at the bottom of add to pool, right? I bet invoke, yep, that uses transform args, transform args, toStir, that's going back to Onyx, right? Here we're adding to pool. Basically, this just keeps track of all the values automatically for you once you've set up the pool. And then you can just call release pooled objects to free them all at once. Now, what if you don't want a value to be freed? Well, that's pretty simple. There's a function on values called release, which basically just says, if there is the current pool, remove this value from the current pool. Oops, sorry. Release is how you actually free it, right? That removes it from the pool and frees it. But the one I was thinking of was actually leak. In this one, it will just remove it from the pool and does not actually do anything with it. And so you can just call leak, which means now you must call release at some point later if you want to. But by default, if you're just kind of like, every event listener, you might like get the document, query for some elements, do some logic, and update the DOM. You can then probably free everything you're doing at that point. Like, maybe that doesn't make sense, but it might be a good idea too. I should say that the heap does have a little bit of deduplication logic in it. Basically, there's this function called get or insert, which I forget where is used. Oh, it's used in that store value, right, where we were looking before. And this is a little bit smarter. It keeps a map of values that just maps the value name to its index. And what this tries to do is use the JavaScript, however map determines equality for JavaScript objects as keys, it tries to use that to deduplicate some of the IDs. I haven't honestly tested this super hard if this like actually deduplicates in the way that you'd want it to, but that is the theory. So yeah, I think I've gone over everything about how JavaScript interop works in Onyx. It's not super magical. It's the only compiler magic is this JS directive that automatically makes the JavaScript for you. Otherwise, it's a lot of just code, and you can just kind of dig into it directly. I should also, I mentioned before, but I'll say it again. A lot of this was inspired. Oh, just testing in a private browser. A lot of this was inspired by Go's syscall.js package. And And so if you look at its API, it will look very similar to Onyx's because Onyx looks similar to it. So they have values and funcs and a really similar API because really it's just the bare bones for abstracting the kind of things that you do in JavaScript. And then you can build things on top of it, right? You could build a DOM library that is now type safe, right? You can just use a bunch of distinct JS values for all the different node types. Or, you know, I've built a, so once you have access to this, you can do a lot of cool things. For example, I have a WebGL2 package that's official from the language that simply defines a bunch of WebGL bindings as these things, and it has a, the JS file that accompanies it. And I guess just to mention this briefly, the way that you would define extra modules if you want to do this, like have a native module that has some JavaScript code that you're not using the JS interop for, but like you write your own JS code for, you simply call the register module function that's on the Onyx class, and you just pass in the name of your foreign module, right, which just needs to match the name that you provide to foreign, and then that you provide to that a closure that takes the instance, and then it returns a JS object that has all the functions in it. So that's how you can kind of do that. And the reason why this works, why I don't have to include anything, is because what actually happens by Onyx package build example, and then I go into the example and I open up the example WASM, or the JavaScript file, you'll see that it starts off just the exact same as what we just looked at, and then right below it is the rest of the JavaScript for the OpenGL. And so basically all the JS directive is doing for you is concatenating all the JavaScript files. There's a specific order that you can use to define it using the pound order, which 0 is the highest precedence, and then by default everything has like int max precedence. So they're all going to be at the end unless you specify a different order. For the most part, it should not matter because this is the kind of thing that you're going to be doing. You're just going to be defining a module, and it doesn't matter the order that these happen because the WebAssembly linker will take care of all that. But this is how you do that. It's relatively easy. And so this enables people to actually go out and like make some things with Onyx, like in the web. Onyx's JavaScript story was really sad before this, so I'm really happy just seeing even just this, right? Being able to click a button, having a alert pop up, and having that all be controlled from within Onyx. It's really exciting. So go out and give it a try. There will inevitably be some bugs, but message me on the Discord, create GitHub issues, whatever you want to do. My phone's battery for the camera is dying, so sounds like I picked a good time.